Welcome to Tolleson Physics. So what we're going to do today is we're going to look at graphs of motion. So we're going to look at position, velocity, and acceleration time graphs, and how can we switch from one to another. So let's switch over to some graphs, and let's come up with a situation. So I'm going to do one that's a little bit different than what we've done in the past. Let's say that the going to the east is going to be a positive direction and going to the west is a negative direction. And I have a runner that's just running at a constant velocity, constant speed to the west. And so they're starting somewhere far away from zero and they're running towards it. So I'm going to draw what that graph is. And you've got to be able to describe the motion from graphs as well. We'll do one example of that later. And so I got a straight line. Why is it a straight line? Well, I said they're moving at a constant velocity. So remember, constant velocity is the slope of that line. That's a funny looking delta. So it's the slope of that line. So now what I'm going to do is I'm going to come up with a velocity time graph right here. And so to come up with the velocity time graph, what I want to do is look at that position time graph and ask myself, is the slope of the position time graph positive, negative, or zero? And does it change at all? So in this particular case, it does not change. So what's the slope? It's negative. So since it does not change and it's negative, I'm going to have just a line with zero slope that's negative in velocity. All that's telling me, so my running position, the way I drew this, they're all positive numbers. You know, once I pass the origin, yeah, they're negative. And I could have kept this line going. It doesn't change my velocity time graph. But the velocity is negative, and all that means in this particular case is I'm running west. Right? So don't confuse positive and negative. You always got to know what direction positive is and what direction negative is. And once you state that, then I said negative is west. I'm just running to the west. All right, and then for acceleration, let me write the slope of the velocity time graph is the acceleration. So the slope in this particular case is zero. Yeah, because I'm moving at a constant velocity, and so my velocity is never changing. All right, so let's think about something else a little bit different. Let's keep going to the west just because it makes it a little bit different. Let's say I'm driving a car, and that car is going fast, and then it slows down at a stoplight. All right, so fast, what does fast mean? Fast means the slope is large. But I'm going to go west, which means I'm traveling in the negative direction based on what I said before. So I'm going to start with a steep slope. You know, I'll round that into a line in a minute. So then I'm going to slow down to a stop. So what does the slope need to be when I stop? Well, that's a velocity equals zero. So the slope equals zero. I don't have to go down to a position equals zero if I don't want to. I didn't say I was getting back to zero. And so then what I'm going to kind of do is make this into a curve. There we go. Kind of like that. Starts with a steep slope up here and then goes down to a zero slope, which means I've stopped. All right, so what does that mean for velocity time? Okay, this one's a little harder because now I have a changing speed. And so what I'm going to do is I'm going to kind of use my pen to draw a tangent line. And so you can see that if I set this here at the beginning, it's steeper and then it gets shallower, shallower, shallower until it gets to zero. So I know that the numerical value of my slope's going down, right? Steep slope to zero slope. Now the question is the slope positive or negative? Well, the way that I drew it, it's going downhill just like the previous example. It's negative. So now I got to put that together for a velocity time graph. So for the velocity time graph, I'm starting with a big negative number. So something down here. I'll make a line out of that soon enough. And then what am I ending with? I'm ending with a slope of zero. And then I'm stopped. So maybe I'll make the stop line a little longer there because I'm sitting at the stoplight waiting to go. Okay, in this class, we're going to assume that we have uniform acceleration all the time. So what does that mean? It means I got to have a straight line for this time period. I'm not going to assume that the acceleration changes. And so I'm going from a big negative number, big negative slope, to zero slope. And then I'm stopped, so I'm not moving. So that's a zero slope. So I kind of have a transition right here, so just to make it easier to see, right? So there's two things going on. So now for the acceleration time graph, I need to look at the slope of the velocity. Well, the slope here, is it positive, negative, or zero? It's positive. It's going uphill. And so it's a straight line, so it doesn't change until I get to that dotted line. And then what happens? It drops to zero. I'm not moving. Now, in reality, can you stop just like that? No, not really. There's going to be a change in acceleration. You kind of make an S-curve. We're not going to worry about that. We're going to look at just kind of looking at the two line segments and going from there. You can't even see my curve. They're so small. But look at this. I have a positive acceleration and a negative velocity. Right? It's negative because it's below zero. This is positive because it's above zero. When I have opposites, that means it's slowing down, which is what part of my story was. We're slowing down. All right, so let's look at a slightly different situation. Let's look at a graph. Actually, let's go ahead and throw something in the air. We'll throw something in the air, right? We'll throw something up, it'll come down. We'll say up is positive, which is fine. So here's an XT graph. And so when I throw it up, after it leaves my hand, I don't care about it touching my hand. It's going to be going fast. So it's going to have a steep slope to start with. Eventually it's going to get to a turnaround point. And that turnaround point is when it's switching from going up to going down. And then it's going to come down, and it's actually going to be very symmetrical. It kind of looks like a parabola. And so now we're going to look at, right, change in velocity. Actually, velocity equals change in position divided by change in time. And so what do I start with? I start with a steep slope, and it's positive. So for my velocity time graph, I'm going to start with a big positive number. And then let me just kind of draw a dotted line in the middle where it turns around. Okay, so it turns around there. What's the slope when it turns around? That's flat, right? So that is a slope of 0. And then it turns out this slope is the same as this slope. We'll learn why eventually. But that slope is the same as that slope, but it's not positive anymore. It's negative. So it's going to be the same number, and it's going to be negative now. And if I draw this properly, it actually turns out when I throw something in the air like that, I get a straight line. All right, and then the last thing is acceleration is change in velocity divided by change in time. Okay, so this is a negative slope that never changes. So that's a negative slope that never changes. So there's my negative slope that never changes. And actually one of the things that we'll eventually figure out is this is at a number of 9.8. Turns out it's meters per second squared. We'll usually round it to 10. All right, so that is what we're going to see when something is thrown in the air. And we'll get into that a little bit more. So let's change things a little bit. Let's go position time. Let's go velocity time. Let's go acceleration time. This will be our last example. All right, I'm going to not start from a story this time. I'm just going to draw a graph. And actually, I'm going to draw a velocity time graph. Something a little bit different, okay? And so we're going to change that velocity time graph. Let's do something like, let's start positive, keep it flat like that, and then let's go, let's go negative, and we'll go past 0, okay? So we've got a couple things going on here. So we've got, let me just kind of line it up so it's easier to think about. So we've got a change in the line slope there, and then we cross the 0, velocity equals 0 about there. So those are kind of good places to look and try to think what's going on. So I think I'm going to do the acceleration time graph first because I think it's a little easier to think about. Because now what are we doing? We're doing the slope of this graph. So the slopes are already there. So that makes it a little easier to think about. So what's the slope of this first line segment? Well, there's no slope, it's 0. So there is no acceleration during that part. All right. Now what happens? Now I've got a negative slope. Looks actually a lot like this. And so I have this negative slope. Let's say this is a car, so I don't know what the value is, but it's a straight line that stays negative the whole time. And it doesn't matter that it goes through 0, right? So this line doesn't change. And so the acceleration doesn't change. Okay, so let's think about what this means for a position time graph. Well, this right here means I'm traveling at a constant velocity because it's not changing. There is no acceleration. And so this means I need a positive slope up here. And I don't have to start at 0. When I start with a velocity time graph, I could start wherever I want. Most of us usually start at 0, but I'll start a little above 0 just because I can. Why not? Okay, and so I'm going to create a positive slope. It's going to be a straight line because the speed doesn't change. Now I got to think about what is going on after this. So what's going on after this is I have this velocity that's getting smaller until it hits 0 right here. So what does that actually mean? That means I have the steep slope that when it gets to this line, let's estimate it to be about there, it's going to be a slope of 0. So what does that mean? So I'm going to go from this steep slope and I'm going to kind of round it out until I get to a slope of 0. Hard to see the curve there. I made it kind of small, but you get the idea, right? I'm going from a steep slope to a 0 slope because my velocity is 0 there. Well, now what happens after that? Well, now my slope, this tells me the slope of this line. This says the slope is now negative. And it says the slope is getting bigger, right? So I start shallow. And I keep curving, and I'll get steeper, and something like that, as close to a parabola as I can draw. Not very good, but that's the idea. So what's kind of the story that's going on here? We've got a vehicle, let's say it's a vehicle, traveling at a constant velocity forward. It slams on the brakes and it hits the brakes and does a U-turn. Is kind of what this is doing, right? So we hit the brakes to help slow us down. We turn the wheel, and we're only looking at this in one dimension. So we're going to make a turn on a dime, which is impossible, but turn on the dime. And then once I get turned around, I can speed up and go back the way I did, that I came from. That's exactly what this is doing here. All right, so there's 4 examples. The key to understanding this, though, is what's the slope mean? Slope of a position time graph is the velocity. Slope of a velocity time graph is the acceleration. So you've got to use the slope to go from one to the other.